Hi everyone, welcome back to my channel. In this video, I will be discussing how to interpret the results of tests for significance of correlation generated by the SPSS. Now, I have here a fictitious data of 56 students, and suppose we are interested to find out the correlation between the general point average and the mathematics performance of the students. So, to do that, you simply have to click Analyze. Okay, click Analyze, and then you look for Correlate, and then you click Bivariate, and then you input here the two variables that you're trying to correlate. So in this case, we are trying to correlate the general point average and their performance in mathematics. So we have them here in this box. Okay, so we can have some options here if you're interested to find out the means and the standard deviations and the cross product, the deviations, the covariances. Okay, and then you see to it that you tick this box for Pearson correlation, and then we're going to use the two-tailed test, and the SPSS will automatically flag the significance of correlation. Alright, then you click OK. Alright, so this is the result of test for significance of correlation generated by the SPSS. The first value that you need to look at in this result is this one, the 0.507, or that is the Pearson correlation coefficient, and you need to describe this value. Well, there are several authors who provided their scales as to how you interpret this result, but I got here the scales generated by the group of Bermudo, and you can see here that if the value is positive or negative 1.0, then that would mean a perfect relationship. But if it's between 0.71 to 0.90, then that would mean that there's a high correlation between the two variables. If it's 0.41 to 0.70, then that would mean a marked and substantial. But if it's between 0.21 and 0.40, there is a presence of correlation, but a very slight correlation between the two variables. But it's negligible if it's between 0.00 and 0.21. Alright, but since our value here is 0.507, then we can say that there is a substantial relationship between the general point average and the mathematics performance. Now, the next thing, or the next value that you need to look at here is this one, the p-value, which is 0.00. You can see here that the SPSS flagged the significance of correlation, and it says here that correlation is significant at 0.01 alpha level. Okay, but if you have advanced your level of confidence, if you have set rather your level of confidence at 0.05, then you need to compare this p-value to 0.05. But if you set your alpha level at 0.01, then you also compare this to the alpha level, which is 0.01. Alright, so obviously the 0.00 here indicates that there is a significant relationship between these two variables, the general point average and the mathematics performance. So our rule there is that if it's less than 0.05 or if it's less than 0.01, then you reject the null hypothesis, and if you rejected the null hypothesis, then you consider the alternative hypothesis. Meaning to say, we can say that given the result, we can say that there is a significant relationship between the general point average and the mathematics performance of the students. Now, how are you going to report these values using the EPA format? Okay, so I have here example on how you report your the results of tests for significance of correlation generated by the SPSS. So you can say that a Pearson correlation coefficient was computed to ascertain the linear relationship between the general point average and the performance in mathematics. And you can say therefore that there was a positive, substantial, and significant correlation. Do not forget the word here, significant. Okay, correlation between the general point average and their performance in mathematics. And then you indicate the value of R. In this case is 0.507, and the p-value, which is equal to 0.000.